Good morning, Sharmila, Divya, Kanishka, Rahul. Good morning, everyone. Good morning, Kalpak Tamil. Okay, fine. So we are going to start. Keshav, good morning, beta. Now look here, we are going to start structure of atoms. In structure of atoms, first we are going to understand what is exactly taught in the previous part of the class, what I have discussed. First the scientists were having an assumption that atoms are indivisible. Indivisible means which cannot be further broken down. This was the concept which they were using to explain that atoms cannot be further classified. It cannot be further broken. It is the smallest unit. Okay, it is the smallest unit. That was the convention. But after that, they changed the way of understanding by when they started understanding no, atom has something inside it. Okay, then a cathode ray experiment. That cathode ray experiment is exactly Keshav, good morning, beta. The cathode ray experiment was one of a very important part, and that part has exactly discussed that something else is present there, and that something is exactly letting the atom not indivisible. Means atom can be further broken down, and they started discussing about the subatomic particles. The subatomic particles. Then what are the subatomic particles? Then we started understanding that okay, there are subatomic particles, and they are neutron, proton and electron. Neutron, proton and electron. But neutron, proton and electron discovery, Vishal, good morning beta. Good morning, Vishal. Okay, neutron, proton and electron were there, but the discovery of that was very unique, and it is exactly exciting. I'm just going to discuss about the cathode ray experiment. Okay, the cathode ray experiment I'm going to discuss about. Just 1 minute. The screen is... it's not fixed properly. I hope now it is okay. So now cathode ray experiment. I'm just going to discuss. Just 1 minute. Just see this one. You can see that okay, after that discovery means they came to know that subatomic particles are there. And what are the subatomic particles? Can you type and send me what are the subatomic particles? Tell me the subatomic particles. Electron, proton and neutron. They are called as what? Subatomic particles. Means the particles which is present in the atom. The particles that is present in the atom are called as subatomic particles. What are they called as? They are called as subatomic particles. So subatomic particles are those that are exactly present in the atom. Electron, proton and neutron. Electron, proton and neutron are the subatomic particles. Now where neutron and proton is present in the nucleus, the electrons are present in the extranuclear part, that is in orbits. Fine. So this was the preliminary concepts, so which I have exactly discussed. What did I said right now? I'm just repeating my point that neutron and proton is present in the nucleus and electrons are exactly revolving where? In the extranuclear part. Where the electrons are present? The electrons, very good Sharmila, the electrons are exactly present in the extranuclear part. Fine. So they are exactly called as extranuclear part, means except the nucleus, the region near the nucleus is called as extranuclear part. The region near the nucleus is called as extranuclear part and electrons were present there only. Now we have to understand some very important point. I am just underlining the most important points there that you have to exactly note down in your note. So we know that atoms, in the further part of the discovery, now I'm not going to talk about the further part of the discovery where how the scientists were. We know already that in the previous sections what and all we have discussed, so we are not going to go there. Directly we are going to start from the point that okay, we are going to now talk about only subatomic particles and how they have discovered. Fine. So now we are going to discuss, in a way we are only going to talk about the discovery of the subatomic particles, electron, proton and neutron in this chapter. So the atoms has its own inner structure and it is made up of subatomic particle, smaller particle present inside an atom. So what are the subatomic particles? The subatomic particles are smaller particles that is present inside the atom. Fine. So this was the most important thing. Now atoms are made up of 3 subatomic particles. What are the 3 subatomic particles? Electron, which is exactly negatively charged particle, then proton, positively charged particle, neutron has no charge, it is exactly neutral particles. So neutron is not having any charge, it is neutral. Neutron is having no charge, it is neutral. I repeat, neutron is having no charge, it is neutral. Did you understood this point? Come on, quickly tell me. Did you understood this point that now we are exactly in that phase where we have a perception that no, atoms are not indivisible, it is having subatomic particles and these subatomic particles are electron, proton and neutron. Electron is negatively charged. Electron is present in extranuclear part, means in orbit. Okay, outside the nucleus in orbit electrons are present and these electrons are negatively charged. Then inside the nucleus proton and neutrons are there. The proton is exactly positively charged and neutron is neutral. Neutron is neutral. I hope you might have understood. So electron, proton and neutron, you have understood this point. Then we will go to the next important point. Now this point already we have discussed that proton and neutron are present in the nucleus. Nucleus is responsible for entire mass of the atom. So this is another key point I am just discussing, that when we see an atom now, so back to back I am just discussing the most important point. I want everybody to be right now, don't sleep. First thing, evening class, again chemistry class will be there. I'll ask all the questions back to back. Right now I'm teaching, so you have to be very, very particular right now. Listen to me very nicely. Those who are absent, offline class I will meet you, just don't worry. Now listen. So now we are discussing that extranuclear part, electrons are present and neutron and proton is present in the nucleus. Now the atom is having a structure. Then what is contributing to the mass of the atom? Which part of the atom is contributing more for the mass of the atom? Which part of the atom is contributing more for the mass of the atom? Good morning, Jiva. Which part is contributing more, nucleus or the electrons present in the extranuclear part, or the electrons present in the extranuclear part? Then your answer will be, auntie, you know that the mass of the atom is just because of the nucleus. So nucleus gives the mass of the atom. Nucleus gives the mass of the atom. Like when I'm talking about my mass now, then I'll be telling that whatever composition is there, my mass is because of that only. From my hair to my leg, everything is contributing for my mass. But when I'm talking about atom, we understood one thing, that when I'm talking about atom, Kanishka, good morning. Yes, understood, Kanishka, super. So now look here, atom, when we are talking about atom, that particular moment we understood one very important point, that okay, for atom something is contributing for its mass, and that something is nothing but it's exactly nucleus. So nucleus is responsible for the entire mass of the atom, which is responsible for the entire mass of atom. If somebody will be asking you this question, what answer you are going to give? What is responsible for giving the mass of the atom? Which one is responsible for giving the mass of the atom? Then what answer you are going to give? Which is responsible for giving the mass of the atom? Sharmila has written nucleus is responsible for giving the mass of the atom. Very good, Sharmila. So now electron are even lighter than proton and neutron, and they revolve rapidly around the nucleus in circular orbit called energy level or shells. So these circular orbits now on which electrons are revolving, they are exactly called as energy level or shells. What they are called as, correct Rahul, that is exactly called as what, beta? Nucleus. So Kanishka has also written the answer nucleus, Rahul has written the answer nucleus. That is absolutely correct, beta. So in nucleus only, the entire mass of the atom is due to the nucleus. So if somebody will be asking you, Rahul, what is your mass? Then you will be saying that, auntie, you know what, that my total mass is me only. Means I am representing, I am going to, my mass is me only. So that means atom mass is atom only? No, the entire mass of the atom is due to its nucleus. The entire mass of the atom is due to its nucleus. Don't forget about this point. Now the extra nuclear part, the orbits are exactly there. So what we have discussed right now, that the orbits now, these are exactly called as energy level. What we are calling it as, they are called as energy levels or shells. Okay, energy levels or shells. So these orbits are called as energy levels or shells. Repeat with me. These orbits are exactly called as what? These orbits are called as energy level or shells. Orbits are called as energy level or shells. What these orbits are called as? So the orbit in which the electrons are revolving, they are exactly called as what? Energy level or shells. What they are called as? Energy level or shells. The orbit in which the electrons are revolving are called as energy level or shells. Absolutely correct, Sharmila. They are exactly called as what? Energy level or shells. Vishal, Keshav, good morning everyone. I am seeing that only some children are responding and they are giving the answers. Yes, Sharmila Jiva has responded. Because morning I don't know you are sleeping or waking up. You just said me good morning, and after that I am not seeing you active. So that does not mean that I am not active. So I am doing my work. I want my children to do their work. Type and send the content what I am just teaching you right now. Fine. So now we have understood that these orbits are exactly called as what? Energy levels or shells. Lower energy level, the inner orbits are called as lower energy level. Orbits of lower energy level, the higher one is called as orbits of higher energy level. Okay, so lower energy level, higher energy level. Correct, Kanishka. Lower energy level to higher energy level. So the lower orbits means the inner orbits are called as orbits of lower energy level, and the outer orbits are called as orbits of higher energy level. The outer orbits are called as orbits of higher energy level. The inner orbits are called as orbits of lower energy level. I hope you might have understood this point also. The inner orbit, orbit of lower energy level. The outer orbit is orbit of higher energy level. Understood? Quickly tell me fast. Yes. Inner orbit, lower energy level. Outer orbit, higher energy level. To the point content we are going to study today. So now so have you ever thought that why the atoms of different element are different for each other? If the atoms are divisible, then what kind of particles are present within the atom? So this content we are going to understand. So now we have to understand one another important point here. I'm just telling you this point. Okay, I'm just telling you this point, just be specific for this. Like this is exactly orbit of lower energy level, the one outside the inner orbit is the outer orbit, this is orbit of higher energy level, lower energy level, higher energy level, that's it. So now we are going to talk about one experiment, and we are just going to understand that why we said that atoms are divisible, because there should be some concrete answer now. Like somebody will wake up one day and they say that, oh, electrons are also be further broken down. So when I am going to stand and say that electrons can be further broken down into sub-electron particles, means I am just saying like insane. So I should give you some concrete proof now that 100% electrons can be broken into subatomic particles. So sorry, sub-electronic particles. So I'm just explaining this point, that electrons can also be exactly going to be there should be something inside electrons also, like that. If I'm saying that, means I should have some concrete answer for this now. I should give some concrete answer for electron also breaking. Okay, so now some concrete concept has to be there. In the same way, when someone is standing and saying that atoms are not what you called something like the smallest unit, it is having subatomic particles, then there should be some concrete proof related to that one. Okay, so now let's see the concrete proof exactly what is. We are going to see that. So procedure, we are going to do one small work. We have taken a plastic ruler, and in that plastic ruler, the plastic ruler is nicely rubbed with an woolen piece of cloth, and after that we kept the plastic ruler near some bits of paper. You know this experiment. Now can you tell me what will happen if after rubbing a plastic ruler with an woolen piece of cloth, and then exactly keeping it near the bits of paper, what will happen? Come on, quickly grab the point and say what will happen. What will happen when it is exactly going to go near to the bits of paper? When after rubbing it, when it is going near the bits of paper, what will happen? When it will go near the bits of paper, what will happen? Come on, just use the concept and tell. So then you will say that yes, the plastic ruler now, it will exactly tiny bits of paper, if I am going to take it, then something will happen. It will stick in the scale. Very good, Sharmila. So the exactly what point is going to happen? Vishal Keshav, good morning. Good morning. Yes, Kanishka, it will absorb the paper. No, it's not about absorbing, it's about sticking with it. Absorbing means it is taking it inside. Okay, so it is not going to absorb it, it is exactly going to stick the paper on it. Stick the paper on it, and the paper will not be sticked forever also. It will be sticked for a while, and after that it will again get released. It will stick for a while, and after that again it will get released. Again it will leave the paper. Okay, so like that it will attract, like that its activity will be there. Okay, like that activity will be there. Fine. Okay, Keshav. That activity will be there. So when we bring the plastic ruler near the bit of paper, the paper bit cling to the plastic ruler. Cling means stick to the plastic ruler. On bringing the glass rod near the plastic, you will observe that the bits of paper will cling to the glass rod. So again, if I am going to bring the glass rod also, if I am going to bring my pen also, I will do like this in my hair, and I will try to take this one near the bits of paper. The bits of paper will stick to my pen also. So that is something is there. After rubbing it, something is appearing on the surface. Something is appearing on the surface. I'm just repeating my point. So when I'm rubbing the ruler with a woolen cloth, and if I'm rubbing glass rod with an woolen cloth, or if I'm rubbing this on my hair and I'm bringing it near the bits of paper, it is clinging, it is sticking here. So why it has been done, and that is temporary, it is not permanent. Yes or no? It is not permanent, it is temporary. For certain time only it is going to stick, and after that it is exactly going to release it back. Then what is the reason behind it? That means the bits of paper cling to the plastic ruler or the glass rod, because on rubbing the plastic with woolen cloth, the plastic ruler gets an electric charge. So that means what? Some charges will be there. Okay, so the concept of charges came here. So concept of charge says that when I'm just rubbing my pen on my head, on my hair, so exactly what is happening, that this is exactly getting charged. So some charged particles are exactly going to be present there. So this charged particle will have the capacity to cling the bits of paper, to cling the bits of paper. So now so similarly, on rubbing the glass rod also with silk, the glass rod gets the electric charge. So now you must be thinking from where this charge came from. This charge came within the atom of plastic ruler and glass rod. From the above activity, it is clear that some charged particles are present within the atom of matter. So this is a very important conclusion. So what is the conclusion what we have drawn from it? So the conclusion we have drawn from it is the charges came within the atom of the plastic ruler and glass rod. The charges came from where? The charges came from the atoms of the plastic ruler and glass rod. So the glass rod, the plastic ruler, the pen I am using, so this charge is exactly coming from there only. So the atom with which the ruler, the pen, the glass rod is made, that atom is exactly giving that charges. That atom is giving that charges. So from the above activity, it is clear that some charged particles are present within the atoms of matter. So this has exactly switched on one bulb inside our brain, that okay, every matter is made up of atoms. So that was the previous discovery. Now the matter is exactly made up of atoms, and the atoms can have charges in it. The atoms can have charges in it. Come on. So what we have understood, what is our finding right now? First we said that matters are made up of small particles, and these particles name they have given as atoms. So now our finding change, and we said that these atoms can have charges in it. So one new extra fitting we have added in our concept, and we came to say that these atoms are exactly having charges. These atoms are having what? These atoms are having charges, and this concept treatment we have done with this example. Okay, I hope you might have understood this point. Come on, quickly tell me, this point you have understood or not? Yes, this point you have understood or not? This point, come on, quickly say you have understood. Understood this point? Yes. So matter are made up of atoms, and atoms have charges. Yes. So till there is a guide, and now we have exactly guided ourselves from one concept to the other concept. Now our concept is partially changed, and now we have focused ourselves into another important point, that yes, atoms do have charges. Yes, atoms do have what? Atoms do have charges. Fine. So now this is our finding. Now we are going to understand discovery of electrons. So for discovery of electrons, first you have to understand discharge tube. So now this is exactly a special type of tube that is exactly called as discharge tube. So this tube is called as discharge tube. So now first we are going to discuss about discharge tube. So this tube is exactly called as what? Discharge tube. What this is exactly called as? This tube is called as discharge tube. This is exactly made with glass. Okay. So the discharge tube is made with glass, but not like the other normal ordinary glass. This is having high durability. It can withstand, means glass is exactly bad conductor of electricity. So inside it, very nice amount of current we can allow to run. Fine. So now we are exactly going to discuss about discharge tube experiment. So this J.J. Thompson experiment is also called as discharge tube experiment. So now what is this discharge tube experiment is about? So now let's talk about this discharge tube experiment. So J.J. Thompson, by brilliant experiment, discovered electron in 1897. So when he discovered these charges, so right now we understood that atoms have charges. Now we are going to talk about the first charge. What is the type of charge present in the atom? It was first discovered by J.J. Thompson, and in the year, which year? 1897. 1897 he has discovered it. Okay, now J.J. Thomson used a discharge tube. So what is the discharge tube? This is a discharge tube. The discharge tube is a special glass tube commonly known as discharge tube, and this tube is 25 centimeter long. What was the length of the discharge tube in which he has done the experiment? The length of the discharge tube in which he has done the experiment was 25 centimeter. What was the length? The length was 25 centimeter. Fine. Now we provided with two electrodes and an arrangement connected to a vacuum pump such that pressure of the gas can gradually be lowered. Okay, so now here the discharge tube was having an arrangement. So what type of arrangement the discharge tube were having? The first arrangement in the discharge tube was the discharge tube was having a pump. So with the help of the pump, we can be able to take out the pressure. So we can reduce the pressure of the discharge tube. So it is exactly having one extra fitting, that is the pump, and with the help of the pump, we can be able to take out the pressure. So I'm just telling about pressure. So exactly we can be able to take out the pressure. So now what happened in this story, I'm going to discuss this story in much details. Okay, so now that pressure can be taken out. So vacuum pump is there. With the help of the pump, we can reduce the pressure of the entire inside part of the discharge tube, and exactly two electrodes were there. Electrode plates were there. Electrode plates will be there, and that was connected with a very high amount of current. So that is 10,000 volt of current can be allowed to pass through these electrodes. Okay, 10,000 volt of currents were allowed to pass through this electrode. That was the concept of J.J. Thomson. Fine. So now we found that when pressure is lowered to 10 to the power minus 1. So I am going to discuss in my own point because I am not satisfied with this content. So I am going to explain the part very nicely. So here 10,000 volt of current was there, which is exactly allowed to pass through the cathode ray, which was exactly allowed to pass through the electrodes. So that see, one simple concept is air is a bad conductor of electricity. To be frank, air is a bad conductor of electricity. Air will not allow electricity to pass. Tesla was someone who was wanting to allow the current to just move in air. That was a different thing. That is a different concept. I'm not going to go there. I'm just talking about that. Okay, if one live wire is there, then that live wire, until and unless you will not touch that live wire, naked wire, you will not get electric shock. Why? Because the wire is not allowing the, like wind now, wind can be traveled from one place to another now. Like that wind, the current cannot pass in the room. Otherwise the story might have been different, because then though if one live wire is, then the electrons will start moving and anyone can get which will come in, go inside that room, anyone can get electrified. Okay, so that is not the concept. Until and unless you will not go and touch the wire, naked wire, you will not get electric shock. So this is exactly proving a very important point, that air is a bad conductor of electricity. Air cannot allow electricity to pass inside the room. It can only be done when you are going to touch that one. It can only be done when it is exactly you are going to touch that one. Otherwise you are not going to get that. Fine. So now that means now he has his ambition was very high. He exactly tried to do one small thing, that is two electrodes he has taken, and after that it allowed a very high amount of current to pass through it. He just wanted to see that given a very high amount of current is exactly allowed to pass through the electrode, will there be flow of current here. So what will happen inside the discharge tube? That was the basic idea for the discovery. Fine, I hope you might have understood till here. So this ray is considered as negatively. Now we have to exactly go inside the experiment and try to understand what actually happened inside the experiment. Okay, so vacuum pump was there, this electrodes were there, two were there, one cathode were there, one anode. So now we are going to talk about the electroplates. So we are just going to understand that, you know, zinc, that is a specific one I have taken because I didn't got that discharge tube. So I just took this one, but I need to draw that one. I think this one is the best one. Vacuum pump is there. Now that is fluorescent coating is there. I think I should draw better. So exactly what had happened there, that one. So actually this was the discharge tube, cathode is there, anode is there. So A and B, cathode and anode. Hmm? 10,000 volt of current. Fine, potential difference of 10,000 volt has been maintained there. Fine. Now what happened after that? Now initially when the pressure was not lowered, so when 10,000 volt of current passed, then what happened? Nothing happened. When the pressure remains the same, the pressure like atmospheric pressure, room pressure is exactly there, the air pressure was exactly normal, no change in pressure. So first what he did is he did not reduce the pressure. First he took the normal room temperature, normal room pressure exactly he has taken. Now when he took that pressure, he saw that nothing happened. So when 10,000 volt of current also passed, now nothing happened inside. So now he reduced the pressure. So now at 1 mm pressure, so now first work is from the vacuum he reduced the pressure and he took the pressure to a level of 1 mm. So when he took the pressure to 1 mm, okay, so when he took the pressure to 1 mm, then the tube started glowing. The entire tube started glowing. Okay, so that was not the success part, because now entire tube is glowing. So we cannot be understanding now something. If an atom has something, then it should have a specific direction of flow. Okay, so now once the pressure is reduced to 1 mm, now that time the entire tube started glowing. So entire tube glowing means success or failure? Tell me quickly. Entire tube glowing means, is it a case of success or failure? Quickly say, because I am thinking everyone is sleeping. So come on, tell me the answer. Entire tube glowing means it's a case of success or failure? That is 1 mm of mercury pressure. If it is exactly there, then the entire tube started glowing. Then it is a case of success or failure? What happened, beta? First, normal pressure. Normal pressure means no change has been done inside the discharge tube. No change has been done inside the discharge tube, and then they allowed current to pass through. So when the current passed through the electrode, nothing happened inside the electrode. Nothing happened. No color showing, nothing showing. Means no color change. Nothing has been exactly seen in the discharge tube. So that was there. Okay. I think it is a failure only. Yes. It is a failure, Vishal. Actually, it is a failure, because now what happened when you reduce the pressure. So first, by taking the normal pressure, nothing happened. Then he reduced the pressure to 1 mm of mercury. So that is exactly 1 mm of mercury means 1 mm of Hg. When the pressure is reduced to this level, that is what correct, Sharmila. So when the pressure is reduced to this level, so once the pressure got reduced to this level, what happened? Now entire tube started glowing. Entire tube started glowing means, is it a failure or a success? Then entire tube is glowing, so we are not going to get a specific idea what is exactly we are dealing with. So what he did is, again he reduced the pressure. After further reducing the pressure, now the color, some color bands started forming, some dark band between the electrodes, means dark color bands were exactly formed in between the electrodes. So that is again we gave the idea that keep on further reducing the pressure, because I think the correct answer is in reducing the pressure. So okay, the correct answer is coming in reducing the pressure. When the pressure is reduced to this level, 0.01 mm, 0.001 mm, I guess I'm just going to change this one, 0.001 mm, okay, that is to this level. When the pressure is reduced now, then the opposite part of this cathode started glowing. Okay, so this part started glowing, not this section, this part is exactly started glowing. Then why this glow is coming? Okay, why this? Yes, correct, Rahul, that was a failure only. So why that glow was coming? So exactly the discharge tube completely the current, and there is no light emitted by the air. The tube appear completely dark. However, the glass wall of the tube exactly opposite to the cathode glow greenish yellow light. So greenish yellow light, it is exactly glowing with greenish yellow light. I am discussing a very important point. I want my children to not have a half idea. I want you to have a complete idea. Okay, that what was exactly the discharge tube experiment. First, in the discharge tube, pressure was normal, nothing happened. Then normal means electricity was passing through the electrode, nothing happened. Then since it is connected, electricity passed, nothing happened. Then it reduced to a pressure of 0.1 mm. Then the entire tube started glowing, and then further reducing of the pressure means dark band of color, something like that appeared. Then again they reduced the pressure to this level, means they keep on taking out the air from there. They kept on taking out the air from there. So air means the whatever air is present inside the discharge tube, they kept on taking out the air, so that the pressure will keep on getting reduced. So when they reduce the pressure to 0.001 mm of Hg, then they are saying that the entire discharge tube is no color is there. Only one place the color will be exactly seen, and that is opposite to cathode. Opposite to cathode, this region only, some greenish, yellowish greenish, some color appeared in this region. Okay, some color appear in this region. I hope you might have understood now. Some color appeared in this region. So some color appeared in this region. Now what color is exactly appearing there? So now he named, that means definitely something. So at this pressure and this amount of current, 10,000 volt of current, and this pressure, something started moving from this electroplate, this plate, and it started going towards this. So that means that definitely something started coming out from one plate and it started moving to the other. That's why only now one colored formation is here. The color formation is here. Till here everybody understood? Till here everybody understood, means something came out from one and it started going towards the other. So at which pressure? 0.001 mm of pressure, something started coming out from the one electrode, that is the cathode part, and it started traveling. Which was not there in the previous cases, but at this pressure it is started exactly traveling. I hope till here everybody understood? So now he named the rays. So these rays, exactly what name J.J. Thomson has given? He named these rays as cathode rays. So what is the name given to these rays? The name given to these rays are exactly cathode rays. Now you have understood this point. The name given to these rays are cathode rays. What name he has given? He has given name to these rays, and that rays name is exactly cathode rays. Okay, cathode rays. What is the name? Cathode rays. Yes. So just type and say What is the name of the ray? What is the name of these rays? The name of these rays are cathode rays. Now there are properties of cathode rays. Come on. So if these rays are so much powerful, it is exactly having the property to cast color. So that means definitely some important part must be there about this cathode ray. It is exactly coming out from, yes, cathode rays. It is exactly called as what? It is called as cathode rays. So my children are very nicely participating today and answering the questions. That's well done part. So it is exactly called as what? It is called as cathode rays. Fine. So this is exactly called as what? Cathode rays. Fine. So I hope you might have understood this. So now properties of cathode rays. Canal rays also we can call, but canal rays are positively charged. Cathode rays are negatively charged, Keshav. So canal rays are positively charged, cathode rays are negatively charged. You have to remember this point. Cathode rays are negatively charged, canal rays are positively charged. I am going to discuss about canal rays also, don't worry. So now I am going to discuss this point. Now they have some properties. So now we have to understand the properties of cathode rays. Evening, stick to me, evening today I am going to teach you the properties of cathode rays. Okay, so evening will be a very fantastic class, and evening class I am going to discuss about the properties of cathode rays, and very interesting fact about this I am going to teach in evening section. Fine. So I am going to keep the class till now only. Fine. In evening section I am going to teach it. Okay, canal rays, cathode rays, next class I am going to discuss about it. Fine. Evening 4 o'clock is the timing. Inform your very intelligent friends that they are going to miss the class if they will not be listening me. Fine.